Okay, good evening and welcome to Master Talker online class. Today we'll be looking at work, energy, and power. First of all, what is work? We call it work done. Okay, work done is simply the product of force and distance. When there is not a distance, you can never say that a work is done. Okay, if there is no distance, work is not done. So work is what? Just the product of force and what? Distance. That's all. Okay, now what if I have a body? So which means work done is equal to what? Force times distance. Okay, and it is measured in joules or measured in Newton meter, because force is measured in Newton and distance is measured in meter. Okay, so Newton meter, but the main SI unit is joule. Now another thing you need to consider is if a body is inclined at an angle theta, how do you find the work done? This is F. How do you find the work done? Remember that we are resolving this thing. Don't forget our all St. Teresa's college. Okay, before this thing move to a distance like this, we have to resolve this force horizontally. So are we resolving towards the angle or against the angle? You see, we are resolving towards the angle. So therefore, work done, okay, is equal to what? Force cos theta times what? Distance, which is what? Fs cos theta. Okay, so depending on where you are resolving to. Now another thing we need to look at is energy. Before we start solving problems, energy. Now for energy, do I say that energy is the same thing as what? Work done. Or let me just define it. Energy is the ability or capacity to do work. Energy is the ability or capacity to do work. Okay, the SI unit is joule. There are various forms of energy, like mechanical energy, electrical energy, heat energy, or heat or thermal energy, etc. However, our interest here will be on the mechanical energy, which is one of the forms, which is of two forms: the kinetic energy and the potential energy. Okay, so we have types of energy. Now energy is the ability to do work, and we have different types of energy like we read here. Then the next thing we look at is what? Potential and kinetic energy. For potential energy, we are interested in just the calculation. The potential energy is what? mgh, mass times acceleration due to gravity times height. Now potential means something is at rest. Potential energy means the energy at rest. Okay, while the kinetic energy is the energy in motion, which is the formula is half mv squared. Okay, and the principle of conservation of energy said that energy can neither be created nor destroyed. Okay, which means the potential energy should be equal to the kinetic energy. So don't forget this formula to help you very well. That potential energy is equal to what? Kinetic energy. In fact, it's still equal to work done. Why? Because all of them are measured in joules. So know that what? Potential energy is mgh is equal to kinetic energy, which is half mv squared, and is equal to work done, which is what? Force times distance. Okay, this formula will help you very well. It will help you very well. Okay, so the next thing we're going to talk about is power. The next thing we'll talk about is power. Then we'll start solving problems. Power is simply what? Work done over what? Over time taken to do that work. Or you say what? Energy over time. Anyone you like. Okay, so which means power is equal to work done is what? Force times distance over what? Time. Or you say what? mgh over what? Time. Or you say what? Half mv squared over time. Anyone you like, you will get the same answer. Okay, so the SI unit is watt. It's measured in watt. power is measured in what? In watts. Or don't forget that work done is measured in joules, and time is measured in seconds. So joule per second. We can use joule per second or what? Or watts. So let's take some questions. The first question here said, number 1 said, calculate the work done in moving a body over a distance of 10 meters along a horizontal plane if a constant force of 15 Newton is applied parallel to the plane. Okay, solution. Now, all these things they are talking about is not our business. Our business is that we are going to get what? That our distance is equal to what? 10 meters. And our force is equal to what? 15 Newton. Therefore, work done is equal to what? Force times distance, which is what? 15 times 10, which is what? 150 joules. As simple as that. 150 joules. Okay? So let's solve the next question. Number 2. Number 2 said, calculate the work done in moving an object along a horizontal plane over a distance of 20 meters by an applied force of 50 Newton at an angle of 60 degrees to the horizontal. So now you can decide to draw it. We applied an angle at 60 degrees to the horizontal, and this is the force we are applying. Okay, and we want this force to move a distance from here to here, which is 20. Okay, so now when you want to resolve this thing horizontally, don't forget your all St. Teresa's college. Okay, we are resolving towards this angle, so I'm going to use cos. So therefore my f there should be what? F cos theta, which is what? My f is what? 50 cos 60. So my f there is what? 50 times 0.5, which is what? 25 Newton. That is my force. So therefore my work done is equal to the same force times distance, capital letter force times distance, which is what? 25 times the distance is 20, which is what? 25 times 20 is 500 joules. Okay, so that is that. The next question, or let's keep solving here. So the next question said, number 3. Number 3 said, Ekene pulls a cow with a force of 80 Newton using a rope to a distance of 50 meters. Find the work done. Okay, to find the work done is as simple as the force he applied is 80 Newton and the distance is what? 50 meters. So work done is equal to 80 times 50, which is what? I think it's 4,000 joules. Okay, you see, as simple as that. So the next thing we will look at, is number 3. Okay, number 4. And number 4 says calculate the work done by a man of mass 60 kg, carrying a block of mass 25 kg up a building of height 8 meters. Okay, so let us calculate the work done. Okay, let's calculate the work done. The work done is first of all the total mass. Solution: the total mass here should be what? The mass of the man, okay, plus the mark of the block, which is what? 60 plus 25, which is what? 85 kilogram. Okay, and we know that work done is the same thing as what? Potential energy. Don't forget. And potential energy, the formula is what? mgh, which is what? 80 times g is acceleration due to gravity, 10 times the height is what? 8, which will give you what? 1600 joules. Okay, as simple as that. Question number 5. Question number 5. Number 5 said calculate the work done if a body of mass 4 kg is allowed to slide down an inclined plane of length 12 meters long with an angle of inclination of 30 degrees. Solution: okay, so I have a body like this. This is the inclined angle 30 and the body is here. Okay, now don't forget that the mass of a body acts downward. So this is the mass of the body, mg, acting downward, and we need a force that we use to what? That we are going to apply. This is the force we are applying. Okay, and then okay, to slide, not to pull it up. The force is sliding down. This is the force we are applying to slide this thing down. Okay, this is the force applied to slide this thing down. So we're going to have that okay, so work done is equal to what? Kinetic energy. And kinetic energy is what? mgh. Okay, which is what? The mass of this body is what? The mass of this body is 4 kg. But this thing is sliding down the plane with an angle like this. So this force, or let me just calculate the force. Let me not use this one. Let's calculate the force. The force that will require to slide this thing down. Don't forget that we are resolving it towards the angle because it's horizontal. So it's going to be what? The capital letter F should be what? Small letter F cos theta, which is what? What do we have? The force required, okay, sorry, if the force required to slide this thing down, listen, is the force that is going to pull it up. because if you are moving, if this angle is moving up, okay, if this angle is moving up, that means this thing will fall down. But if you are bringing it down like this, it's not going to fall down. So the angle we are resolving vertically, we are not resolving horizontally. Okay, so don't forget our all St. Stephen College, St. Teresa's College. So we are resolving against the angle, so we use sine. So the F now should be what? F sine theta, okay, which is what? mg sine theta, okay, and my m is 4 times 10 sine 30. So what do we have now? 4 times 10 times 0.5, which is what? 20 what? 20 Newton. So this is the force that is required to slide this thing down, okay. For this thing to slide down, we are resolving vertically. So therefore the work done should be what? The force times the distance, which is what? 20 times 30, which is what? 60 joules. Okay, how did I get that? Sorry, times 12. The distance is 12, not 30. 12. So which is what? 240 joules. 240 joules. Okay, so the next thing we are looking at, number 6. Number 6. And number 6 says a body of mass 6 kg moves with a velocity of 15 meter per second. Calculate the kinetic energy. So calculating the kinetic energy solution, I'm having that what? Kinetic energy is equal to what? Half mv squared. So which is what? 1/2 times 6 times 15 squared, which is what? 3 times 225, which is what? 675 joules. As simple as that. Number 7. Number 7 say calculate the kinetic energy of a body. Kinetic energy of a body of mass 60 gram moving with a velocity of 72 kilometers per hour. Okay, solution. Now we need to convert it. The velocity there is what? 72 kilometers per hour, which is what? 72 times 1000 divided by 60 times 60 to convert it to what? Meter per second, which will give us 20 meter per second. So the next thing we have to convert is what? Converting gram, the mass, to kilogram. The mass there is what? 60 gram. Now how do you convert gram to kilogram? Sometimes I don't know if I should multiply by 1000 or I should divide by 1000. Look at what you do so that you don't make mistake. Don't forget that 1000 gram is equal to 1 kilogram. Okay, so write gram under gram. So 60 gram should give us what? X kilogram. So cross multiply to have that 1000 x is equal to 60. So x will now be what? 60 divided by 1000, which will give what? 0.006. Okay, 0 cancel 0, 1 2. Okay, 0.06 kilogram. So this is set as 0.06 kilogram. So now to get the kinetic energy, let me clean this, it's not part of this. Okay, getting the kinetic energy is equal to what? Half mv squared, which is what? 1/2 times 0.06 times 20 squared. So what do you have? If you do the math, you are going to get 12 joules. 12 joules. Okay, so the next, let me check our time. So okay, so let's continue. Number 7. Okay, number 8 now. Number 8. What is the potential energy? What is the potential energy? What is the potential energy of a body of mass 70 kg at a height of 4 meters above the sea level? Solution. Okay, now we have mgh as our potential energy, which is what? mgh. My m is 70 times acceleration due to gravity is 10 times the distance 4, so everything will give you, I think, 2800 in joules. 2800 in joules. So the next question, question number 9. I think I should be reading the question than writing. They said a stone of mass they've given us mass. A stone of mass 0.02 kg, okay, moving with a speed of 200 meter per second. The speed is the velocity, which is what? 200 meter per second, okay, eventually hit a wall of which the average resistance force is 8,000. The average resistance force is 8,000 Newton, okay. Calculate the distance penetrated by the stone. Okay, they say that a stone of mass 0.02 kg moving with a speed of 200 meter per second eventually hit a wall of which the average resistance force is 8,000 Newton. Calculate the distance penetrated by the stone. Solution. Now we know that kinetic energy is equal to what? Potential energy. And kinetic energy is what? 1/2 mv squared is equal to what? The potential energy there is mgh. Okay, now the stone is moving with this, okay, and it's still the same thing as what? Work done. I hope you know. Work done. And work answer is equal to work done. And work done is what? Force times distance. Okay, so let's use these two. Let's use these two to get our distance. I'm going to have 1/2 times the mass is 0.02 times the velocity is 200 squared is equal to what? 8,000 times s. So my s will now be what? 1/2 times 0.02 times 200 squared. Everybody divided by 8,000. So if you do the mass, you are going to have 0.05 meters. Okay, 0.05 meters if you do the mass. Okay, so your parameter will help you to know what you are looking for. Now the next question said a steel ball of mass, they've given us the mass of mass 30 kg. A steel ball of mass 30 kg falls from a height, they've given us the height 80 meters, falls from a height and penetrates into the soil 200 millimeter. Penetrates into the soil 200 millimeter. So the distance of penetration is 200 millimeter. Okay, 200 millimeter deep. What is the average resistance force of the soil? The average resistance force of the soil, okay, is very simple. But before that, we need to convert millimeter to meter. So how many millimeter will give you 1 meter? I think 10,000 millimeter will give you 1 meter. So 10,000 millimeter is equal to what? 1 meter. So here now, 200 millimeter should be equal to what? X. Cross multiply. So therefore x is equal to what? 200 divided by 10,000. So I'm having 0 cancel 0, 0 cancel 0. I'm having 0.02 meters. So this is what? 0.02 meters. Okay? So what do we do now? We know that potential energy is still work done. Potential energy is mgh and is equal to work done. Work done is what? Force times the distance we are looking for. So which is what? 30 times 10 times the height is what? 80 is equal to what? My force that I'm looking for times the distance I have is what? 0.02. So therefore my force is what? 30 times 10 times 80 divided by 0.02. So my answer becomes 123 Newton. Okay. So that is that. So the next question. So the next question said a catapult used to hold a stone of mass. Look at the mass of the stone, 500 gram. Okay? Where is the question? 500 gram, which is what? 0.5 kilogram. I've taught you how to convert. Okay? Is exerted by 20 cm with an applied force. Okay? If the stone leaves with a velocity of, the velocity of the stone is what? 50 meters per second. And the distance moved, the extension or the distance, we can call it extension or the distance, is what? 20 cm. If you divide by 100, you have 0.2 meters. Okay? So they say, what is the value, okay, with an applied force F, if the stone leaves with a velocity of 40, not 20. The velocity is 40, not 50. Okay? 40 meters per second. Calculate the value of F. A catapult used to hold a stone of mass 500 gram is extended by 20 cm with an applied force F. If the stone leaves with a velocity of 40 meters per second, what is the value of F? Okay? Okay, so the next thing we are going to look at is we need to look at the force. The force is what the problem is. So, but we know that that work done is equal to what? Kinetic energy. So work done is force times distance is equal to what? Kinetic energy is what? 1/2 mv squared. Okay, but in this one now, we are looking at the extension there, and the work done in an elastic material is what? 1/2 force times what? The extension. Okay, this is an elastic material, so it's equal to 1/2 mv squared. So half will cancel half, so I'm left with the force, which is what? The force I'm looking for times 0.2 the extension is equal to what? 0.5 times what? 40 squared. So my F will now be what? 0.5 times 40 squared divided by 0.2. So my answer becomes 40,000 Newton. 40,000 Newton. Okay? So that is that. The next question. The next question said, a body of mass 4 kg. The mass of this body is 4 kg. Okay? A body of mass 4 kg is acted upon by a constant force of 12 Newton. The force that acts on this body is 12 Newton. Okay? For 10 seconds. The time is 3 seconds. Sorry, for 3 seconds. The time is 3 seconds. What is the kinetic energy gained by the body at the end of the time? what is the kinetic energy gained by the body at the end of the time. Okay, and we know that that force, what is the kinetic energy? Okay, we need to get the mass. We need to get the mass here. They say that the mass of that force, okay, but we know that kinetic energy is equal to what? Work done. Okay, and the kinetic energy there is 1/2 mv squared, okay, is equal to the what? The work done. The question said we should calculate what? That we should calculate the kinetic energy. Okay, so we are looking for mv squared. Mv squared, 1/2 mv squared. Okay, so the mass there is 4. So I'm having 1/2 times 4 times the velocity is the problem. We don't know the velocity. Okay, but I know that force is equal to what? Mass times acceleration. Okay, which is what? 12 is equal to what? 4 times a. So the acceleration there is 12 divided by 4, which is 3. 12 divided by 4, which is what? 3 meter per second square. Okay, and we know that acceleration is what? Velocity over what? Over time. So velocity is what? Acceleration times what? Time, which is what? 3 times what? 3, which is what? 9 meter per second. So I have gotten the what? The velocity as 9. So it will now be times 9 squared. So I'm having 2 times 81, which is what? 2 times 81, which is what? 162 joules. Okay, 162 joules. Okay, so the next question. Another way we can solve this thing is that we know that impulse is the same thing as what? Change in momentum. I hope you know. Impulse is equal to what? Change in momentum. And impulse is force times time. Impulse is what? Force times time is equal to change in momentum is what? Mv is momentum. Final minus what? Initial. Okay? Initial. Mv minus mu. So the impulse is what? Force, which is 12 times the distance there is the time there is 3. Is equal to what? I'm looking for velocity now. So the final velocity, I'm having the m in bracket of v minus u because they are moving with one mass. So I'm having a what? 48 is equal to the mass there is what? 4. Okay, I'm having 12 times 3 is equal to 4 bracket v minus 0. Okay, because the initial velocity there is 0. So what do I have? 48 is equal to what? 4v. So v is equal to, is it 48 or 36? 36. So v is equal to what? 36 divided by 4, which is what? 9 meter per second. So I have gotten my velocity. So with the velocity now, I can calculate the kinetic energy. Kinetic energy is what? 1/2 mv squared, which is what? 1/2 times 4 times 9 squared, which is the same 162 joules. Okay, which is the same 162 joules. Okay, so the next thing we'll look at is oh, thank you very much. Next video we'll talk about time, power.